Hello everybody. Today I'm going to be doing a demonstration on the bigram language model I wrote to show you guys that we can protect integrity in machine learning models by encrypting the data first, sending in the data, and then training the model on that data. This will have like a proof of concept to show that we can protect the integrity of what kind of stuff goes into models to where we can like stop fake news that's being created by machine learning models. So before we start, I just want to say this is the model right here. You're gonna need an A100 GPU at least if you want it to run it in like a reasonable amount of time, maybe like 20-30 minutes to train the model and stuff like that. If you try to train it on your regular computer, it'll take about like 2, maybe 3, even 3 days to train. This is the training loop right here. Right before that, we're gonna write out the number of parameters to the screen. Every 500 steps, we're gonna evaluate the training loss and the validation loss just to see where we're at and to see we want those to be low so the model mimics the data as well as possible. The more training, the more like the data set it will be, but until then, like it'll try to mimic the data best it can. Here, I'm printing out 500 characters to the screen, and then I'm also printing out 10,000 more to a file called more.txt. So before we start, I want to encrypt the data. So this is just a basic Caesar cipher that my groupmate wrote for me to run these tests with. Just before we start, I want to show you the input to encrypt file. It's a large data set of Shakespeare text. And for this, it won't really matter, like this proof of concept, it won't really matter what we encrypt it with. But this Shakespeare text will be our like data set that we encrypt. So let's just run that. 3. Okay, so it should have encrypted it. Let's look. It put it into our put here.txt. Our put here.txt, yes, it did. So there's our put here.txt. Everything looks encrypted all the way down. This right here will protect the integrity of this Shakespeare data that we're using. Furthermore, I'm already logged into Sun, the high-powered GPU that I'm going to be using to train this model. So I just want to show you guys that we have these files right here, this more.txt. Let's take a look at it. Sorry, I was into the wrong file. I meant to access the put here.txt. Put here.txt. Let's take a look at that. Put here.txt. Yes, we see that it followed the same kind of encryption. It looks like the new lines got lost in the Linux when we were transferring up to Linux, but as you can tell, it's the same kind of encryption. ILW, FLW, bracket HP or HQ. Same kind of stuff, and I'm trusting that it goes all the way down. I see do, and then oops up. Yeah. So trusting that it went all the way through in our case here, and yeah. So that being said, um, I want to take a look at the bigram language model before we start. We have it over here on my VS Code, but on Linux it's going to look a little bit different. So here I'm going to be training the data on the put here.txt, which we just saw was the encrypted file. On my local machine I have it as input just because I was doing some stuff before this. But yeah, and with that it should, let's go into insert mode real quick. I just want to see where will it print out this data once we have it all right in the contents. It will print out to generated.text.txt. Okay, So with that, we should be all good to go. Bigram.py. Let's start the tests. So as you see, just right now, it starting the training loop. Um, Before it starts the training loop, we print out the number of parameters just because all we did was assign the model to the device, and then we're printing out the number of parameters that we're using, and then we had set the optimizer, and now we've started the training loop. Step 0, training loss 4.22, validation loss 4.2306. So we're right now in the first step of this. So it's gonna go for the max iterations, which up here I have it set to 5,000. Somebody can have it set as much higher, but I think 5,000 would be like, it's typically a pretty good number when you're training a small language model like this. So we should be okay there. We're gonna we're expecting to see this training and validation loss to go down, and even this validation loss to be a little bit better than this training loss. So we have some like overfitting. So it shows that the model is not losing much data, but is now able to start creating data that actually mimics the input text data. Sorry. And now we wait. This process usually takes about like 15 to 20 minutes on this A100 GPU, but I tried running it on my regular computer and it took about, I want to say, 2.5 days, maybe, maybe even a little bit more than that. I ran it on a virtual machine, so it didn't like stall all my programs, but it was definitely like way too long. If you don't have access to a high powered GPU like this one, then you're gonna be able to run the program without a doubt, but you just won't be able to like reap the benefits of its reward. So I definitely suggest, if you want to run something like this, or if you want to like test this out at home, make sure you have access to a high powered GPU. I'm not sure if you can do that or not, but yeah. I also want to take the time to say thank you to Dr. Hina for giving me access to, or SSH access to Sun. It's the GPU here we have at the school. A lot of the researchers use it to train the machine learning models they're creating. So this was a very interesting thing for me to like go in and play with it and figure out how it works and train my own machine learning model on it as well. We see we're here at step 500, and we're already, training loss is already getting lower, and validation loss is already so we're already starting to have this overfitting. It's already starting to like mimic the data in some kind of way. We can see that our training loss is starting to get smaller and smaller. We definitely want it to be as small as possible, and our validation loss is starting to get bigger, a little bigger. It went down in size, but there is like some deviation between the iterations. But so far, it's looking like that is like working it properly, and we should be able to. At the end of this, we should be able to have some pretty good data to work with. We're at step 2500. Validation loss is getting real. I mean, the training loss is getting really low, and the validation loss is starting to grow. So, doing pretty good. Getting it closer and closer to zero, which is really good. Validation loss is like seeming to go up now at this point, which is expected. We're about halfway through, so I'm expecting this to be a lot higher than this one. I'm expecting this to be maybe about zero point 0.2. I'm expecting this to be closer to 3 or something. So far, we're about like, I want to say 7 minutes or so into the training. So I'm assuming we'll finish at like 15 minutes or so. And nobody, and you don't have to like necessarily do this step, but I like to keep track of just the training and validation loss, just so we can, so I know what I'm working with, like specs wise at least. If I like were to draw a conclusion about the model and how it's behaving, because essentially all it's doing is this loop right here, and you can get rid of this statement right here. This is just the training loop itself. All you really need is to get this training batch. The losses and logits would be the model, like the key value pairs in the model, which we'll be talking about later. The optimizer would be 0 grad set to none, which would be true. Then the loss of propagation would be backwards, and optimizer would step forward to project the next step. The context, and then we print the decoded, and we also write out the decoded encryption, or the decoded contents of the model. We'll have to decrypt the data after the model is done training it. Because essentially, if I were to abstract all this stuff right here would be in a file on its own, and the rest of it, like all this stuff up here, would just be in a file on its own as well. Um, except maybe this stuff as well. No. Max iterations can be in a different file as well. Like these parameters can be these hyperparameters could be set in a different file, but I ideally want to keep all of this. Actually, from characters all the way down to the training loop to right here, right before the training loop, you probably want to abstract that just so nobody like messes with the training and like breaks the model or like messes too much with the levels and how the dimensions run and like the levels of like threading. So because if you enter some of these wrong numbers incorrectly, then you could you could essentially mess up how the validation works, and then you'll be left with a model that just didn't really like train data properly. We're at step 4,000, 80% done, and like I expected, training loss is getting closer and closer to zero, and validation loss is growing closer to 3. I expect it to finish out around 3.7 or so, maybe 3.5, but this is this is good. Or it's as expected. Maybe it's not perfect, but it is as expected. I'm gonna use this later, just in case, just in case. because we are approaching the end of the training steps. So we're about to hit the 4,000, yeah, 4,999. This is the 5,000 step to start at zero, 4,999. See, now we printed the 500 characters to the screen, and it's still not done because it's printing 10,000 characters to the generated text for me. So I'm gonna go ahead and copy this and save it, just because I just want to make sure if it gets lost. Save as. Let's call this the backup for right now. Yeah, I guess printing out the 10,000 characters and saving it to the generated TXT file will take a little bit longer, but shouldn't take too long. After that, we're gonna run it back through the encryption function. We're just gonna change these over here and push it through. See if the integrity of the model was held true after the encryption. Okay, it looks like it just finished. So let's take a look at everything. This generated.txt file is where we told the bigram model to place the data. So let's take a look at that. Just as I expected, the file is all filled in with things. Wonder if I can copy all of it. Okay, looks like I cannot. This is why I have the backup just in case. Let me just see something real quick. Um, can I create a new file? Okay, so I wasn't able to copy the file's contents directly from the generator.txt, but it's the same kind of contents that were printed out to the screen. So I'm gonna decrypt it now with the encryption function that we used earlier. Called it backup. Is it like that? Backup? Yes, backup. And then I'm gonna put it into this hope.txt file because I'm hoping it works. Just kidding, I know it works. Theoretically, this should work with whatever encryption, but let's see. Decrypt. And we used the value of 3 earlier, so we're going to use it again. So now, let's open up this hope folder. And here we go. It looks like the spacing was a bit off because of how the Python open and string functions work. They tend to like grab everything as one function. They don't make new line. I mean, everything is one string. They don't make new lines. But you can see here that after decrypting the data in backup, we were able to get to this stuff. And that's exactly what we thought was going to happen. It speaks in the same sort of manner as the input.txt, although it's not perfectly Shakespearean, but clown, respect my bark by the room, all filler. Romeo, thou thy tender part, let me hear it. I have heard thou thy harm bird, I am banished, lo here, sir. Very Shakespearean-esque, right? So this concludes the demonstration. Um,